what exactly is a semiconductor chip? How did this industry become so powerful? Why countries like US and China fighting?
This industry started in 1960 to 1980s. So anyone who wishes to go into this field, they should choose.
Hello everyone, welcome to Juhi Avaneesh Show. Today's topic is something that powers the entire world, but very few people understand it. From your mobile phone to laptops, cars, AI and even defense system, everything runs on it, and it is semiconductor chips. But have you ever wondered what a semiconductor actually is? How silicon turns into a chip? And why countries like US and China are fighting over this tiny piece of technology? To talk about this, we have Avaneesh with us today, who has been working in this silicon industry for last 15 years and understands how this industry actually works from the inside. So we will talk about the importance of semiconductors, how chips are made, the business and investment side of this industry, career opportunities, and why the industry is considered the future of the world. So let's start. Avaneesh, how are you? Welcome on our show.
Hi Juhi, thank you for inviting me to your show. ये मेरा favorite topic है, semiconductor.
Amazing. It's good to know that it's your favorite topic, and that's why I have picked you. So I know you are a master in this field. So let's start with an amazing question, and the question is, everyone uses phones and laptops, but very few people understand silicon. In simple words, what exactly is a semiconductor chip? Can you please explain?
A semiconductor chip is a tiny electronic brain inside your digital device, which is your phone, your laptop, your washing machine, your fridge, your TV. So in simple words, अगर हम इसको simple words में बताएं तो this is the brain which actually makes your device smarter. And one example of that is that if you take it with your example with your body, so that is your phone, and if your mind, that is your chip. So this is what silicon in a chip is there. Why it's called semiconductor? Because it's half conductor and half insulator, and you can control when it is going to be a conductor or when it is going to be the insulator. So this is the basic of this technology. Usually it is made of silicon, that's why it's called a silicon chip. And you also hear the term Silicon Valley. In India it's Bangalore, in US there's a Silicon Valley. Europe is also trying to build a Silicon Valley for itself.
ये बात तो आपने बिल्कुल सही कही, और from mobile phones to AI, everything runs on chips, right? So how did this industry become so powerful?
So very simple. जैसा कि आपको पता है ये सेंचुरी जो है वो टेक्नोलॉजी की है. And when you talk about technology, these chips, which are the brains of that technology, are very, very important. Like every application like AI, drones, mobiles, defense, missiles, everything is dependent on these chips. So whoever controls the manufacturing of these chips, they are the person or the people or the country or the companies who will control the future of the technology. And whoever controls the future of technology, they will control the future. So they are very, very important. This industry is very old actually, if you see. This industry started in 1960 to 1980s when there were very few companies. All of them were in US. They were like IBM, Texas Instrument, and they started building these chips. And at that time, very, very few people actually knew how to make these chips. But when we were busy in everything else, these companies were shaping the future of the world. And they are now building the most advanced chips in the world. So they control how this world currently runs on these chips. So whoever has access to these technology, they will rule the future. Then जब हम बाकी का वर्ल्ड जो है वो रेडियो, टेलीविजन और एंटरटेनमेंट में बिजी था, तब ये कंपनीज हार्ड वर्क करके नेक्स्ट जनरेशन ऑफ टेक्नोलॉजी पे वर्क कर रही थी. Right now everyone has a smartphone in their hand. And because of these smartphones, drones, cameras, the demand for these chips actually exploded. And right now there are very few companies who actually make these chips. Few of them are like Apple, Samsung, Qualcomm. These ones are now very, very powerful. And then came AI. With AI, we now need the most powerful chips. And these chips are called GPUs. And one company right now, which is called NVIDIA, they have the best GPUs in this world. And because they are the ones who have these most powerful chips, they are very much in demand. Their chips are very much in demand all across the world. So now, if you are right that NVIDIA is the most valuable company in this world,
of course.
They have like trillions of dollars of worth of valuations, and anyone who has shares of these NVIDIA, they are like millionaires and billionaires. So this is how this industry is becoming powerful day by day, because everything from your smart home to your smartphone, everything runs on these chips. So there is one more thing you should know. Even though NVIDIA AI chips को बनाता है, AI GPU chips को बनाता है, but क्या आपको पता है कि वो सिर्फ उसका R&D करता है, वो एक्चुअली उन चिप्स को मैन्युफैक्चर नहीं करता.
But why?
because उनके पास plant नहीं है.
Oh.
There is another company which is very important in this whole process. It's called TSMC, Taiwan Semiconductor Manufacturing Company, based out of Taiwan.
Oh, I know, and we all know why. But still, I would like to ask this question. Why countries like US and China fighting over semiconductor chips?
So as we mentioned that these chips, they are everywhere. Chips का access right now, जो most advanced chips हैं, वो सारी US based companies के पास हैं, like Qualcomm, Intel, Texas Instrument, Nvidia. And these companies are really powerful today. और US actually block कर रहा है चाइना को या different other countries को कि उनको access to this technology नहीं मिले. So that only they have exclusive access to these advanced chips, ताकि उनके data centers mostly advanced हों. और it's not just about business anymore. It's also about your national security.
Okay.
And China is the one country which wants to be self-dependent. That they can make their own chips. So that's one of the reason that you will hear a lot of news that, okay, US wants to restrict the technology transfer to Chinese companies. Because US की सारी बड़ी companies have this access to this advanced technology. And China is trying to build fabrication companies.
Okay.
So that's the reason, whole setup, जिसमें China और US are fighting each other to access this one.
Yeah. Okay.
One more thing.
Yeah.
So as I mentioned earlier, हमने एक कंपनी का नाम लिया था called TSMC, so Taiwan Semiconductor Manufacturing Company. और most of the advanced chips, as we mentioned, like Nvidia, Apple, इनकी सारी की सारी chips tape out होती हैं TSMC से. And TSMC is the only company which is right now taping out 2 nanometer technology chips. हम इसके बारे में और बात करेंगे जब हम इस प्रोसेस पे जाएंगे कि ये टेक्नोलॉजी क्या है, मैन्युफैक्चरिंग कैसे होती है. बट आप ये समझ लीजिए कि 2 नैनोमीटर इज़ द मोस्ट एडवांस्ड नोड. और राइट नाउ बेस्ट यील्ड अगर किसी कंपनी का है 2 नैनोमीटर टेक्नोलॉजी में, वो TSMC का है. और TSMC इज़ वेरी क्लोज टू चाइना. सो देयर इज़ अ र्यूमर, okay, that China is trying its best to capture Taiwan. It's not about geography anymore. It's again the semiconductor chips.
Okay. Now I understand this.
Thank you.
Is silicon the new oil?
You can say so. Like हम जब 60s और 70s और 80s और 90s की बात करते हैं, तो सारी दुनिया was focusing on energy. Energy security was the first thing which comes to your mind when we were talking about 60s and 70s. सारी दुनिया की ग्रोथ हो रही थी उस टाइम पे. We were coming out of 2 world wars. तो सबका रिक्वायरमेंट था एनर्जी सिक्योरिटी. सो best source of energy security is fossil fuels, which is oil, coal, and everything. And out of that also, most of the developing and developed countries transport, right? So oil was the most important commodity at that point of time. But if you see today's world, अब जैसे आप कोविड से पहले की बात करें तो ट्रैवल बहुत रिक्वायर्ड था किसी भी चीज़ को कंप्लीट करने के लिए. आपको सेल्स पिच करनी है, यू हैव टू गो टू द क्लाइंट्स प्लेस. अभी एवरीथिंग इज डन रिमोटली.
That's right.
And when you are talking about remote work, you know semiconductor chips come into picture. And then we have AI now. And with AI, you can't even imagine the number of semiconductor chips required to run those data centers which are used for AI. They are like huge. So the companies or countries who have access to those technology, they are going to sell those chips to everyone. So just like energy security के लिए oil required था, ऐसे ही टेक्नोलॉजी के सेल्फ डिपेंडेंस के लिए आपको सिलिकॉन चिप्स का एक्सेस होना चाहिए.
Okay.
तो ऑयल, जस्ट लाइक ऑयल, दिस इज अगेन अ बिजनेस पॉइंट ऑफ व्यू. सिलिकॉन चिप्स आर वेरी इंपॉर्टेंट.
That's why India and Europe are trying to get the semiconductor fab.
Yes.
So what are the main steps in making a semiconductor chip? Can you please explain?
There are 2 parts of it.
Okay.
One is research and development, which is design and development. And second part is actually making these chips in a factory. R&D and design and development is completely separate. As I mentioned to you in the first question, right? That Nvidia is the most valuable company in this world.
Yeah.
But they don't make their chips.
Yeah.
They only do design and development of it.
Development.
So, and then there is a company called TSMC. They never do any design and development. They only manufacture these chips. So there are 2 parts of it. One is the factory itself and one is the design and development. So let's discuss the second part of it, which is the semiconductor plant itself.
Okay.
So in that one, there are different steps. The first step is that you get a silicon wafer. A silicon is something which you get in sand.
Yeah.
But it's not sand.
It's
the
not sand.
most purified form of silicon. So you get sand, you clean it, and there is only silicon left. Then you make it and then you make a circular disc type of wafer out of it, which is called silicon wafer. That's the first step, that you need to have a pure silicon wafer. A pure silicon wafer is insulated. There is no electricity which can pass through it. So then how do you make it semiconductor? So that's where this next process comes. So what you do is that you use a very expensive printing machine. You say printing machine?
Yeah.
It's called EUV lithography.
Okay.
So it's like very, very fine optical based printing. What it does is actually that it cuts circuit out of that simple wafer and decide that what are the places where which transistor or which part will go. The next part comes out is called etching. So in etching, what you do is that you actually take out the rest of the part which is not useful. So you just throw it out, you can clean it out. And the next part is called doping. So as I mentioned you, right, that one is completely insulated. There's no electricity can flow through it. So what you do is that you carefully inject impurities into, chemical process impurities into that silicon wafer. And the places where you put that, those places become semiconductors. How they become semiconductor? If you apply voltage to them, a certain voltage, they will start conducting electricity. So doping part is done, and now you do this over layers over layers. Once that is done, your silicon wafer is ready. But first you need to test it, whether this is a good chip or not. So first you test it, then you cut it, because in one actual wafer, you can make a lot of chips, depending upon what is the size of your chip. So you have to cut them into smaller pieces. Once that is done, you go to the packaging. And now you say, what is packaging? You already have a chip. So silicon is very thin wafer. How will do the connections to it?
Right.
There is no ports coming out of it. So in the packaging process, there are outer layers are there, which we pack them into it, and then you put layers there for the connections. So that is called the packaging process. And then the chips are shipped out to its parent companies, the company who has actually designed them, like NVIDIA. The first batch, once they get it, they put it into an evaluation board. There, it gets tested for its features, whether it's working as it is supposed to or it's not. So then, once it passes that test phase, then it goes into mass production, and then you get it to the customers. So this is like one short, concise way of putting it together. So
Okay. And then it ends here? No?
no, that's the second part.
Okay.
And then comes the design and development. This is where you put a lot of money.
Money? Why?
Yes. Because it can take up to 4 to 5 years to actually make a chip which is going to work in the field, in the customer's hand, from concept to delivery. And most of the time which is spent is in the design and development cycle. And for that, there's so many processes of it. The most important part of it is called architecture. You know, just like to build a house, you need an architecture for it.
Yes, of course.
Simple and very similar that, okay, we are going to make a chip, but what do you need in that chip? So that's where the architecture comes into picture. So that's one of the job options there.
Okay. Another option for job.
Job.
Yeah.
Next phase is that once the architecture is decided, you break that architecture into different parts of it, because it's going to be a lot of things you need to do to actually make that chip. So those parts are divided into designers. Someone is designing, say, memory. Someone is designing a CPU. Someone is designing a communication protocol. So all these things are designed, and this is the first step is called RTL. It's a term which we use in our industry, but I thought I will use this keyword so that everyone knows what it is. And then comes the verification part. The verification is the most important part of this whole process, because unlike software, if your device is not working after it's taped out, you cannot fix it. It's a brick.
Okay.
And remember that if you go to a shopkeeper who fixes a phone, and if there's a chip which is gone bad, what he will say that I will get a new chip and put it into your board.
Yeah, of
because
course.
you cannot repair it.
Yeah.
So it's very simple. So the next part which we are discussing, like verification, that is the phase where you test that this design is as per expected architecture, and it works on certain clock cycle. That means how fast it is. What is the latency of it? That means from input to output, how much time is it taking? And there are different kind of applications जहाँ पे आपको different speed चाहिए. Like एक कार के डिज़ाइन में the time between input and output cannot be long. क्योंकि वहाँ पे लाइफ का क्वेश्चन है कि अगर एयरबैग डिप्लॉय होने में टाइम लग गया, it's dangerous.
Yeah.
But if you talk about your mobile phone where gaming is happening, it's okay to take more time.
Yes, of
right?
course. Yeah.
So जब हम चिप का डिज़ाइन और वेरिफिकेशन हो रहा होता है, देन वी टेक केयर ऑफ दीज थिंग्स कि ये इसका एप्लीकेशन कहाँ है. डिफेंस का एप्लीकेशन कम्प्लीटली डिफरेंट है, जनरल पर्पज प्रोसेसर का एप्लीकेशन पूरी तरह से डिफरेंट है, रियल टाइम प्रोसेसर्स का एप्लीकेशन पूरी तरह से डिफरेंट है. सो द काइंड ऑफ चिप यू आर मेकिंग, दैट्स द काइंड ऑफ हार्ड वर्क यू पुट इनटू. Next part is once the design is designed and verified, it goes into a physical design team. Now you say, what is a physical design?
Yes,
You already did the
yes,
design.
yeah.
So physical design is that although you've written a logic, which is mostly, if you say compared with the software, you will see the code. If else, if something, this is the input, this should be the output. How it will actually turn into silicon is where the physical design teams comes into the picture. They make this logic which you have written into actual gates itself. And then again, there's one very important part of this is called DFT.
Okay.
It's called design for test.
Okay.
So again, as I mentioned that if your chip is not working, how will you debug it? Why it's not working? You cannot see anything in the chip, right? It's very small and there are very few inputs and outputs coming out of it. So that's where the DFT comes into picture. Today's words, in a typical chip, आपका more than 50% of logic is actually for the test logic. So that's where the DFT engineers come into picture. And then finally the backend. The backend guys, they decide that कि आपकी चिप जो आपका जो रियल स्टेट है, आपका प्लॉट साइज है आपके घर का, उसमें कहाँ किचन होगा, कहाँ मेन ड्राइंग रूम होगा, कहाँ बाथरूम होगा. बिकॉज फॉर द चिप जो CPU है उसके पास रैम बहुत क्लोज होनी चाहिए, अदरवाइज जो इंस्ट्रक्शन फेच होगा वो बहुत स्लो हो जाएगा अगर वो दूर हो गया. ऐसे ही किचन के सबसे पास में क्या होना चाहिए, टैप होना चाहिए. So, ऐसे ही चिप में कौन सी जगह पे क्या फिट होगा, दिस इज वेयर द फिजिकल डिजाइन comes into the picture.
Okay.
So that's the next part. And then finally, when you have full net list ready, it goes to your fab. So that's some concise way of saying that how a full flow of design and development comes into picture.
Yeah, it's so good to know about that. Okay, then I understand this. So is the semiconductor industry a good career option for students today?
Yes, it's as I mentioned that there are so many steps involved, and you need so many engineers at every step. If you're into R&D, research and development, you can go to the first phase of chip building, where the design, development, backend, verification, DFT, all those are career options. But if you actually want to work in a plant, then these plants need really skilled engineers where the actual silicon chips gets made.
Okay.
So anyone who has the degrees or diplomas into those manufacturing methodologies, they are really good career options for them.
After choosing careers on electronics and as a subject, so what kind of jobs are there in semiconductor industry, and why semiconductor factories so expensive?
Once we were discussing the steps to make a semiconductor chip is that you have design and development, the R&D phase, and then the actual chip building phase.
Yeah.
So all those have different steps, and all those steps need so many engineers. So like you have design jobs, you have verification jobs, you have DFT jobs, and then you have manufacturing jobs. Let's talk about why these companies are so expensive.
Why
These factories are the most advanced factories you can think of. First of all, you need very clean water, you need very clean air, and you need really good supply of electricity. Any fluctuations, any fluctuations in electricity can be like catastrophic for the factory itself. The whole batch can be gone. Do you know why?
Why?
Because where these chips are made, they are called clean rooms. So once we mentioned, right, that this is a pure silicon, and we control where the impurity gets. So if there is clean room and if there is even a single particle there, that can actually destroy the whole chip.
Really?
You need really trained engineers, and then there are clean rooms. Before entering the clean rooms, you have to wear a certain design clothes for that.
Yeah.
And then they go through certain process of cleaning themselves. So before going to clean room, you have to go to so many processes before your whole clothes gets clean. That's the one part of it. Second part is that you need really good skilled engineers for that, who are already trained. The third part of it is the plant itself. Okay. So there's only one company in this whole world who actually makes equipment which is used to make these semiconductor chips.
Then
so that's like a monopoly, and that company is called ASML. It's based in Netherlands. And when we were talking about China and US, right?
Yeah.
So what US was saying that ASML cannot sell these advanced EU lithography machines to China, because most of the customers of these semiconductor companies are US based companies. So they want to control who has access to these latest EU lithography machines. And once, let me discuss more on this. So these EU lithography machines are very costly. If you talk about the most advanced nodes, we were talking about 2 nanometer. Those can cost around 700 to 800 million US dollars.
My goodness.
And if you don't want the advanced nodes, still the most used nodes like 36 or 40 nanometers is still out 200 or 300 million US dollars. So that's the one part of it. Second, these machines are very heavy. So you're like 60 to 70 tons of it. So to transport these, you need at least 2 or 4 Boeing 777 planes to it. You cannot carry it into a ship.
Yes, of course.
So you need the advanced transport methods to it. And third is, they have at least 70 to 80 engineers who come to your plant, and they can take up to 6 months to install these machines to your plant.
Okay.
So, and they also are very high skilled engineers. So you see, you have to have a very good power supply. You need to have a very good electricity. You need to have really clean water, and then these machines. So all of this is very costly to build. And out of this, the most important part is the skill set, which is kind of a niche skill set, and it's very limited to few countries. So anyone who wishes to have a manufacturing plant for these semiconductors, they have to go through all that steps and pain to get that. And as I mentioned, there can be political pressures on it that you cannot supply these advanced machines to this country. So that's why this is really, really important. And that's why these are very, very costly.
Okay. So is AI increasing the demand for semiconductor chips?
Yes, certainly.
How?
So these AI commands run on data centers.
Yeah.
And these data centers need a lot of GPUs. And these GPUs need to be made somewhere.
Yeah.
Also, not just the GPU, they also need a lot of memory, which is DDR and RAM. And these DDR and RAMs are also semiconductor chips. So with the advent of AI, you need a lot of GPUs and a lot of memories. So that's why the demand for those advanced silicon chips is exploding. And right now, the whole world cannot supply it. So right now, if you go and try to buy a RAM for your desktop, you will not get it, because all the RAM supply is already into data centers. So that's how much the demand is there now, right now.
So it is increasing.
It's not increasing, it's exploding.
It's exploding. Oh my God, that's really amazing. Okay, so what is the future of this industry? If someone wants to enter this, what should they study?
First of all, the future of this industry is very bright because of AI.
Okay.
The AI needs as many chips as you can build. And in future, you will see more chips which are only doing AI tasks.
Okay.
They will not be the general purpose computers or GPUs. You will see more and more number of these chips being in demand in future. So anyone who wishes to go into this field should choose electronics, VLSI design, verification, DFT as their subjects. And if you go to any university, they have these specialized courses available. So anyone who has interest on these, they should choose those streams, and they can build a really nice future for them.
Wow. Because the future is very bright. Right. Good to know. I would end this podcast with this last question. If semiconductor chip stops for just 7 days, what is going to happen to the world?
You're talking about 7 days.
Yeah.
That's a big time.
Okay.
If these chips for 7 hours, this whole world will like go into crazy mode. Internet will stop working. Your planes will not fly. Trains will not know which path to take.
Okay.
Your traffic signals will stop.
Okay.
There will be chaos on the streets.
Everything.
Everything. Your hospitals, your TV, your fridge, your washing machine, nothing will work properly.
Without chips.
We are so much dependent on these chips. You can't even imagine. And maybe people will actually go crazy without it. So.
Wow, Avaneesh. I'm so glad that I got to know so many things from you. And we will end this podcast here.
Thank you, Juhi. Thank you for inviting me to this talk show. And I would love to hear about it more.
It's a great pleasure. Okay, Avaneesh. Bye-bye.
Bye. Namaste.
आई होप आपको आज का पॉडकास्ट बहुत पसंद आया होगा. बहुत नॉलेजेबल था. सेमीकंडक्टर के बारे में काफ़ी कुछ जानने को मिला. सिलिकॉन चिप्स के बारे में जानने को मिला. But I am so pumped up what we have lined up for the next episode. I'll see you soon for more. Bye. Namaste.